Now that we know how to solve a triangle, let's look at the application of solution of triangle in 2 dimensions and 3 dimensions problems. So let's start with 2-dimensional problems. There are 2 parts in the 2-dimensional problem. The first part is angles of elevation and angles of depression. The second part will be on bearings. Alright. Angles of elevation and angles of depression, they are happening on the vertical plane. Right? Things are mainly going up and down, whereas for bearing it's happening on the horizontal plane. Things are going north, east, south, and west. All right, so there are 2 different. They live in 2 different worlds. You have angles of elevation or angles of depression when you make observations from different heights. All right, if someone is standing on a high point, say this is person A. All right. A is standing here, B is down there, right? If they want to make an observation to one another, first we join a line between them, right? That is their line of sight, alright? And this line of sight, the angle making with the horizontal, is what we call the angles of elevation, alright? This is the angle made with the horizontal, angles of elevation. Whereas the angle of depression from A, now you do not have a horizontal line in A, so we put it back. We put back the horizontal line like this, alright? And then the angle going down from A will be what we call the angles of depression. Angles of depression, alright? Is measured against the horizontal line, alright? Now, so often people make mistake by saying that this is the angle of depression. This is not the angle of depression, right? So let me first clear this misconception, alright? This is not angle of depression. It is not the angle made with the vertical, never. It is always the angle made with the horizontal. Even though we do our measurement on the slope, for example, if A and B, they are on the slope like this, alright? And A is even high up, A is on top of a tree. Alright, we have a tree. And A is on top of the tree, so point A is here. Alright, point B is down here. When we talk about the angle of depression from A to B, alright, so once again, we draw the line of sight between A and B. So this is it, alright? And the angle of depression, we have to recover the horizontal. This is the horizontal. And the angle of depression will be this one. Now, the confusing part is the angle of elevation. What is the angle of elevation from B, alright? Now, once again, so often people were making mistake by saying that this is the angle of elevation from B, alright? Once again, this is wrong. This is not the angle of elevation. Like I said earlier, the angle of elevation, the angle of depression, they always measured against the horizontal. So this is the correct angle of elevation, right? Not that one, not this one, alright? It should be the one made with the horizontal line and the line of sight, alright? This is the angle of elevation, alright? Not that one. So be very careful about this, okay? So other than this one, we have to use the ordinary solution of triangle approach. We find out the focus triangle and see what are the information we can obtain from the focus triangle. Usually you need 3 pieces of information to solve, alright? So let's take a look at the next example. Okay, in this example, we want to measure the height of a tower from a faraway position, right? The trick is, the mathematical strength is that we don't really have to go to the tower, alright? The tower may be far away, may be unreachable, it doesn't matter, alright? We can measure the height of the tower from a remote position, but we need 2 observations, right? We set up 2 observation points, P and Q, alright? And we look up to the top of the tower. Their angles of elevation, they are 15 degrees and 20 degrees respectively, alright? The separation between P and Q is 100 meters. And of course, PQ and the base of the tower, they must be on the same straight line, right? If you look at it from the top, the tower is here, P is here, then Q must be here, all right? Q cannot be somewhere here, all right? That will be another issue if PQ and the base of tower is not on the same straight line, all right? So let me label the point, say this is point B, this is point A, all right? So I will want to share with you two different approaches we can handle this question. All right, we can do it with or without sine formula. All right, so maybe first I show you the way without the sine formula. Without the sine formula, without sine and cosine formula, we rely on the trigonometric ratio. All right, so we have these two triangles, ABP and ABQ. All right, we have these two triangles. All right, so we have ABP is the larger one. We have ABQ is the smaller one. We have the angles. This is 15 degrees. This is 20 degrees. We have H. We have H. All right. But we don't know what is the distance of PB nor QB. All right. So let's say we call this distance A, shall we? All right. This is A in orange. So we know this is A. This is A and 100. All right. So we can use the tangent trigonometric ratio to set up two equations to solve for the two unknowns H and A. So from the first triangle, we obtain tangent 15 degrees will be H divided by A plus H. All right, tangent 15 degrees with H divided by A plus 100. This is in the ABP triangle. And likewise, in the ABQ triangle, we can set up something like this, H over A. All right. This is tangent 20 degrees will be H over A. So we set up two equations in two unknowns H and A. Solving this, we can find the value of H. All right. Upon solving, I'll leave it to you as an exercise, right, to solve for the value of H. Right. You may want to do it now. You may pause the video. I think you can do it in 2, maybe 3 minutes. All right. Try to do that, and then you'll get the value of H. According to my calculation, the value of H is 101.57 meters. All right. You can also get A, but A is not the thing we need in this question, right? Okay, so I didn't use any sine formula nor cosine formula. I only used trigonometric ratio. But there are two equations to solve for the two unknowns. I need an extra unknown A in order to do that. All right. Now, of course, you can do it with the cosine formula, but we need to look at the focus triangle. All right. We can have we need H. All right. In order to find H, we need the focus triangle. In this case, will be triangle APQ. All right, this one. It does not contain H, but with AP or AQ, we can get H with a simple trigonometric ratio. All right, so this is the triangle APQ. All right. So what do we know about this triangle? We know that this is 100. We know this is 15 degrees. What else do we know? All right, we know this angle, this this purple angle will be 160 degrees. Am I right? Because it is the angle on the same straight line with the 20. So this angle is 160 degrees. So this is a classical ASA situation. ASA situation. We can invoke the sine formula to find AQ or maybe AP in the ASA situation, right? Let's do AP. All right. You may try doing AQ if you want to. All right, but in this case, let me do AP. All right. Oh, but I also need this angle. I also need this yellow angle. Right. In ASA, I need the third angle. The third angle will be 180 minus 160 minus 15. It goes 5 degrees. All right. So let me invoke the sine formula. We have 100 divided by sine 5 degrees. All right. Equals to AP divided by 160 degrees. Now, I mentioned earlier that if possible, we use cosine formula, all right? But that is only for finding angles. To find the length of a line, we can use sine formula safely, all right? The only worry is to use sine formula to find angle because of the two solutions in sine formula. If we use sine formula to find length, it is safe, all right? Don't worry about it. So we can get the value of AP, all right? Now, what do we do after we have AP? After we have AP, we can use a simple trigonometric ratio to find the height of the tower. All right. We can go back to the triangle ABQ. All right. To get the H is the height. Oh, sorry, AP will be that one. Sorry, I have to use the triangle APB. All right. Sorry. P is this one. In the meantime, you might want to use the calculator to find the value of AP. All right, this is B, right angle. This is point P. And then once you have AP, you can use the value of AP, put it back into this triangle because it is the same AP. All right, and use a simple trigonometric ratio to get H. All right, we have AP over H. H over AP will be sine 15 degrees. All right. We have H divided by AP will be sine 15 degrees, all right, equals to sine 15. It is a trigonometric ratio. All right, putting the AP back into here. All right. So in this method, the most important, they are the two gray arrows here. All right. The two arrows, they mean the same thing, but on the top one, it is the graphical sense. On the bottom one, it is the equation sense, all right? So I leave the calculation to you, and I believe we come back to the same answer, okay? Right, no matter how you do it with or without the sine formula, the solution, they have to be the same. Am I right? So this is the end of the first part.